So I think we want to talk about this stair as sort of an interesting way, or sort of like a vignette of how you guys realize something really beautiful using a lot of these different tools, right?
Sure. So yeah, absolutely. So upper left, we still do hand sketches. We still use pens and bum wad, and still kind of develop the idea on the drafting table, if you will. But the sooner we can start modeling these things, the sooner we can start working with our engineers to find out, is it possible? And they can do some analysis to find out if it is possible. And a great result of that is in the lower left, we can start to do some quick visualization things to find out if the client is receptive to it. We can study the lighting within these spaces and how sunlight enters it and artificial lighting. And then the middle, on the bottom middle image, starts to show how the steel is lowered into the opening in the structure, and then the final image on the right of the completed project. So all of these things took a lot of different packages and types of software to accomplish. So it's not just we're doing everything in Revit. It took, if you go to the next slide, Mark, we can look a little more at how the structural engineer worked. So on the left is a fabrication drawing from the steel fabricator. You can see all of the nuts and bolts, the rebar that's embedded in the concrete, all of the different pieces of steel that will be ordered and fabricated at offsite. But on the right, Mark, if you click the, I think it's slide 5 of,
Yeah,
there you
this
go.
guy right here.
You can play that little fun animation. So using Tekla Structure, our engineer did a study of what it would mean if a whole bunch of grad students are jumping up and down on the ends of those blue treads there. So that scared the hell out of us when we first saw it, thinking it's going to move so much, but they assured us it was scaled up by 100 just so you could see any movement at all. But that's the kind of analysis that building information modeling starts to allow.
Yeah, it's funny. This reminds me, I used to work with a structural engineer, and he would do the same thing and amplify the movement by 100. And I used to always say, I used to come by his desk and say, hey, can you make the building wiggle? Which is kind of what this looks like, although.
Yeah.
Okay, cool.
So if you go to the next slide, another fun structural engineering animation, you can play that one. So they started to play with tools they have at their disposal to show the thing falling apart as they drop bowling balls on it. So structural engineers do visualization too.
Yeah, and I'm sure we would all agree, only funny in in the not real world.
Of course, yeah. I don't want to see all the treads falling off of the stringer there.
Yeah, cool.
So here, just a couple of the installation photos. The center one shows the engineer standing under it, and yes, indeed, it's staying there. So he was happy about that. Yeah. And then the next one kind of shows the final product of installed lighting under the treads, sunlight coming in the base. Pretty successful little case study there, just involving how much modeling and analysis we were able to do.
Yeah, so going back here maybe, and just thinking about how this thing was built. So if I go back, here is the digital model that that Thornton Tomasetti created on the left. And so, so this model then was sent to the fabricators, and the fabricators probably replicated that model, meaning they made their own model based on it, and then they use that to fabricate and cut all these different pieces. Is that sort of the right idea?
Absolutely. One other piece to that is they used GPS technology with a total station on the job site to locate the embeds exactly, so that this intricate curving one-sided stair would fall in the correct spot exactly.
So like down there, but then also up here, sort of at the top.
So where it hits the curving beam at the top, both ends of that stringer had to hit it in the exact right place.
Huh. Okay. And so when you say GPS located the embeds, and we talked about this a little bit yesterday, but do you mean that they, let me think about this, that they first indicated where those embeds wanted to be, and then brought that geometry back to the fabricator, and then the fabricator kind of used that to kind of adjust the geometry of the stair, or is it the other way around?
It's kind of the other way around. So the coordinates were established in the Revit model with a architecture model and the structural engineers model. Those coordinates were extracted by the fabricators and used to work with the concrete installers to properly place them as concrete was going in. So way before the stair was even being fabricated, the steel guy was having to work with the concrete guy to locate everything precisely.
What is the tolerance on GPS coordinates?
It's nowadays it's pretty accurate. You can if we could zoom in on the bottom of that stringer a little bit, there's a little bit of tolerance for areas where we can weld, but maybe only by half an inch or so of variation or deviation.
Oh, I see. Okay. So it's not like it's to 1/8 of an inch or anything like that, but plus or minus
exactly.
an inch, something like that.
Yeah.
Okay.
Nothing in the concrete world is.
Well, that's what I was wondering. Right. That's what I was wondering. GPS sounds like it might be pretty fancy or pretty precise, I suppose. But okay.
Yep.
So that makes sense. So then they're using that to locate the embeds, and then they're regarding shop drawings. You guys probably got shop drawings. Every single piece of steel is on its own page or something like that, and that's the kind of shop. You didn't get digital shop drawings or anything like that, meaning a model or anything like that to review, right?
We did get digital digital models, but unfortunately nowadays we still can't contractually use those to approve. So we also have to request or make sure that we get physical or paper shop drawings to review as well.
Right. Okay. And Michael W. made a good comment about this. Sort of incredulously, you build the models and you still have to deliver things in 2D. And yes, as Andrew is saying. That still seems to be the case. So
there will be a day when we don't have to.
Yeah. Okay, cool. So let's
frankly, sorry to interrupt, Mark, but frankly, there's a movement or a lot of architects that are wary of that because they feel like that the deliverable and the art of architecture is in our drawing. So there's some angst about that in the industry, but
sure.
Personally, I feel that the art of architecture is the final product, not necessarily the drawings that we deliver.
Right. Yeah, I think we're on the same page on that one, for sure.